just one chemical, and other stuff you will most likely have it at home. So if you can see, we have the materials right here. So here we have copper. These are just copper strips. You can use copper scrap or any form. And then we have a small container, the smallest one I could find, so that we can store the mercury. Ensure it's not airtight, because we don't need an airtight container. We have a syringe. We have the chemical mercuric nitrate. Don't mind the AR, it means analytic research, means it is pure. This is the container we'll be doing it in. As you can see, it's clear. And then here we have our water. Yeah, so before we start, I would like to list some precautions. Number 1, mercuric nitrate is a toxic chemical, and also the chemical we will be getting inside this beaker or the container, it's corrosive, so please handle those two with care. And then number 3, as I said, do not store mercury in an airtight container. It should be such that the air can release, because from time to time mercury releases vapors, so it should not be airtight. So let's begin. So I've already mixed the solution with water. Don't worry, some of it will be solid and a bit hard to mix, but then slowly it will just get inside. So then you'll get something like this. Now what we'll do is we'll put it in our container that we wanted to do the experiment in. As you can see, we have some over here that was not mixed, but don't worry, you can just add a little bit of it. It will slowly get mixed.
Okay.
So guys, as you can see, I have just finished mixing the mercuric nitrate with the water. Now we have this cloudy and kind of sulfur looking water. Okay, now all you have to do is you can, so then if you use copper foil or scrap, you just make balls and then just put them inside. But then we chose to go with strips, because the surface area increases with them. So now you can just take them and now just put them inside the liquid, and then you can just let them rest like that. So while this is happening, let me explain the science behind it. Yeah, so what happens is that this thing is called a single displacement reaction. What happens is that there's something called reactivity series. So the mercury is lower than copper. So then what happens is that the copper will displace the mercury, forming copper nitrate. And then there are 3 metals that we thought could work: aluminium, steel, and copper. But aluminium will mainly react with the water and less with the mercury nitrate. Steel will form a grey powdered form of mercury, which then has to be washed with acid to give you the mercury. So then and then copper didn't just give us the proper mercury we needed, so we used copper in this. So then as you can see, at the top we have, it's starting to form something blue. You can see the blue thing at the top, that is the copper nitrate. Yeah, so then usually the alkali metals will be at the top of the reactivity series, but they can also react with water and cause some chaos. So that's why we don't use it. So then this blue thing is copper nitrate, and now usually it will be formed quickly in just one day, but I usually let it stay for around a week, just so that I can get most of the mercury out from the mercuric nitrate. So you can see the copper nitrate, it's still there, it's slowly going to form, and then soon you get the blue liquid. Okay, so I'll see you after 1 week. Okay guys, so I came back after a week, and as you can see, the mercury has collected in here. Many of you might say this is gallium, but I'll show you why it's not gallium. Mercury. But first, let me just show you. So now collecting this is easy. You just mix that stuff, so then any other powder that has settled at the bottom, it'll just be moving around in the water, and you can use the syringe. Now if you are wondering how I got it this clean, look, when you put it in a syringe, look what happens. It just falls off like that if you just gently shake it. You can see. I'll just do that again. Okay, so look, you use the syringe and suck it up. Now hold it like this so that the mercury does not just fall off while I'm sucking it. Then you can just gently kind of like shake it, and then you'll get most of it out. Some of it will be in there, so then you just hit it on the edges over here at the bottom where you think it could have collected, or where it has collected. Okay, yeah, there. And then you wash the syringe. I'll prove that this is not gallium, because gallium usually loves to stick everywhere. Okay, so look, this thing's not sticking, it's just mercury that's been left. I'll actually put it on my hand right now. Yeah. So look, I've collected mercury. This syringe there's no metal in the syringe once all the mercury falls out. Okay, so look, I'll just put it in my hand right now, and it is dense. Okay, it's very dense. Actually, let's see. Let me actually try to get most of it out. Okay, I got most of it. Yeah, I let one drop fall out. I'll just remove that later. Just look at it. Oh no. I'm getting it everywhere in my hand. That at some points I have to actually remove. Let me just move the camera so that you can see it. Oh no, I'm so sorry. So look at that. That's mercury in my hand right there. You will know it's very dense. Okay. And I'll just bring you back over here for now. And then it's so easy to just remove. You can just pour it out like that. But still wash your hands, because there could be some non-visible mercury on it, of course. So as you can see, it's not gallium. It's not sticking around. That's the main way you can know. And right now it's actually cold out here. Yeah, this week it was cold. Yeah, so this may look like a little mercury, but it's actually a lot because mercury is expensive. So I hope this helped you get mercury at home. So I'll see you in the next video while I'm trying to get this thing out. So till then, peace out.